Hi, this is the Year 7 Elements and Atoms Reverse the Classroom. Alright, so what I'm going to do on this video is I'm going to go through some of the information you're going to learn during the actual unit itself to give you an advantage when you're actually studying within it. Okay, so that then new information that's delivered to you isn't quite as new as it may well could be. Right, and the way that it works is we've got elements and atoms, we've got periodic table, compounds and mixtures, naming compounds, history of the atom, atomic structure, relative formula mass, and then what we do then is we get to review and then we get testing on it. Right, so firstly, definitions. There's three main things: element, compound, mixture. So what an element is one particular type of atom. Right, and it cannot be made any simpler, right, and there's approximately 118. That is your original dairy milk. A compound is made up of at least two elements. Now this is then the most important part of this. So in a compound it's made up of two elements, and I'm going to highlight this in green, that are chemically bonded together. Right, so for example, water is made up of two hydrogen atoms and one oxygen atom, but they are chemically bonded together in a fixed proportion. Dairy milk, fruit and nut. Where you got your chocolate and you got your nuts, they are chemically bonded together, they are all sort of mashed up and you cannot separate them out very easily. That is a compound. A mixture, right, is then where you've got two or more elements, but again, this is then the most important thing. They are not chemically bonded, and I'm going to highlight that now in orange. They are not chemically bonded, which means you can separate them. So for example, air is a mixture. It's got nitrogen, oxygen, carbon dioxide, water vapor, but what you can do, you can separate them because they are not chemically bonded together. Here we go, there's your mixture thing there, right, where you've got different ones, different chocolates, but what you can do is you can separate them out. Here's another example. What I've got is iron, element, sulfur, the element. If I then do a mixture, what I've got is I've got iron and sulfur in a mixture, and what I could do is I could actually get a magnet, right, with a north on it, right, and I can actually pull out the iron because they're not chemically bonded together. If I've got iron sulfide and I bring a magnet next to it, it'll just bring the whole thing, because now what they are is they're now stuck together, because in a compound, which is this one, they are chemically bonded together. Right, model of the atom. Now what happened is, over many hundreds of years, it's been worked out what an atom is like. The first guy, Democritus, he came up with the idea of atomos, which means they are indivisible, cannot be cut. John Dalton came up with the idea that it looked like a billiard ball, right, and that it was a solid sphere, okay, which kind of makes sense really. J.J. Thomson came up with the principle that it was something called a plum pudding, and I'm going to show you a picture of that in a minute. Rutherford, he also came up with some of the most important things, and what he did is he discovered the proton. He also discovered that the nucleus was charged and the electrons were around the outside. Niels Bohr organised the electrons into shells, and then James Chadwick excuse me, discovered the neutron. Right. So these are then the kind of the two main models that ever need to be compared. This is the plum pudding by J.J. Thomson, and this, the nuclear model, is mostly by Rutherford. Now what J.J. Thomson thought was that there were negative charged particles, a bit like plums in plum pudding and Christmas cake. Sometimes it might be called a chocolate chip cookie, where what you've got is you've got negative bits embedded in it, and the rest of it is then positive. Okay, kind of the doughy bit. The nuclear model that we believe now has the nucleus in the middle, which contains the protons and the neutrons, with electrons then flying around in shells around the outside. Right, this then kind of explains it in words. So the plum pudding model consists of a sphere of positive charge, like the dough, with electrons stuck on the outside of the ball, like plums in a plum pudding. or like the chocolate chips on the outside of a chocolate chip cookie. In comparison, the nuclear model, the electrons are in shells, right? And the nuclear also contains a positive nucleus, right, which contains protons and neutrons, right? And then going back to the plum pudding model, the plum pudding model does not contain anything like nucleus, protons or neutrons, okay? It only has kind of electrons sort of embedded into the doughy bit. Now, what do the numbers mean, right? You look at a periodic table and what you do is have the element, which is the symbol, Li, the element name, which is lithium, and then you've got two numbers. These numbers here correspond to something that we'll always call pen. Pen is the protons, the electrons, and the neutrons. All right? Now, just double quickly, just show you how you actually use pen. Pen is, number of protons is that number there. It's a small number. The number of electrons is always the same. And the number of neutrons is that number take away that number. So it would be 7 take away 3 equals 4 is then the number of neutrons. Okay, so now we're looking at our subatomic particles. So that is our pen, protons, electrons, neutrons. Right? The two things you need to know about are the mass and the electrical charge. Right? So we've got protons, neutrons and electrons here. Right? It's in a slightly different order, so just be aware of that. The mass of a proton is 1. The mass of a neutron is 1. Right? Now, there's no units to them. They're kind of relative to each other because they're so light. But protons and neutrons are basically the same. An electron is almost 0. Sometimes it can be written down as negligible. The charge, which is then the second part, is the charge on a proton is +1. The charge on a neutron, think about it, neutron, neutral, right, is 0. And the charge on an electron is -1. Okay, electron configuration. Now, once you've worked out your pen, you've again got your number of electrons, right, what you can do then, you can put them into shells, right? And let's say we've got 15 electrons. What you do then is you put them into your shells, and you've got shell number 1 is allowed, so this circle here is shell number 1, and it's allowed to have 2 electrons in it. As soon as it gets to more than 2 electrons, it's full, and it kind of overspills into the next one. So I've now used up 2 of those, so I've got 13 left. Those 13 then go, 1 goes there, 2, 3, 4, 5, 6, 7, 8. And as soon as it gets to 8, I'm then full again. And then I have to put on another shell. I've only got 5 left now. This example's got more than that. So what you do is you go 1, 2, 3, 4, 5. I've now got no electrons left to put in. And the electron configuration of this is 2, which is the number in the first shell, then 8, then 5. Right? Now, if there was more than 15, then what you would do is, I'll just kind of do it in green, is then you would continue to fill them up until the shell is full, and after that, you then move on to your next shell. Okay, in this section, now what I'm going to do is I'm going to show you how to calculate the molar mass, right, the relative formula mass, right, and we're going to do sulfuric acid, right. First thing you do is you write down the elements in order. Right, so what I've got here is I've got hydrogen, sulfur and oxygen. Hydrogen, sulfur and oxygen. Then what I do is I write down how many of each element. So hydrogen, because there's a little 2 there, that means there's 2. If the sulfur hasn't got a number after it, that means there's a 1. And oxygen has then got a 4 after it, which means there's 4 oxygens. Then you will multiply the atomic mass of each element by how many there are. Okay, so if I go to sulfur, right, the big number, I'll just do it in a different colour. If I go to sulfur, the big number is 32. Okay, and the small number is 16. And what you do is you multiply the big number by the number of elements that there is. So sulfur, I would do 1 times 32. Oxygen's numbers are 16 and 8, so I do 4 times 16. And hydrogen, its numbers are H11, so the big number is a 1, so I do 2 times 1. Right, and then what I do is I add all those numbers up together. 2, 32, because 1 times 32, and 4 times 16 is 64. Add them all together, and my RFM is 98. Now, what you've now got is you've got 5 questions. You need to write these out down in your proper exercise book, and then you need to go back, and then you need to answer them. Right? Most of the answers are relatively short. What does PEN stand for? Who discovered the neutron? What's the main difference between compounds and mixtures? What's the charge on a proton? Not a neutron and an electron. Then the hardest one is calculate the RFM of HNO3. That is nitric acid. And if you notice, next to the H there's no number, which means a 1. If you look next to the N, there's no number, which means a 1. And if you look next to the O, there's a 3, which means there's 3 lots of oxygen. Now, what you've got to do now is you've just got to make sure that you've understood everything that I've gone through. You're then going to get taught this in class, but you're going to have now a pretty good idea about what you're actually going to get delivered through your teacher.